Hey everyone, this is Richard with ORCASAT Computing. I just wanted to take a couple of minutes and walk through some of the code and how it's organized in this project. Now, if you're watching this video sometime after it was recorded, this may be somewhat different, although I don't imagine it will change too much because the way things are is how we've had them for quite a while, just a little bit cleaned up and things like that. So I've got the OBC2 firmware opened in CCS, and I'll just explain what a couple of the different directories do. So the platform directory is where all of the Halcogen generated code ends up. So Halcogen creates for you everything in the include and everything in the source directory. And for the most part, we don't edit these files because when they're regenerated, Halcogen will pretty much create them from scratch almost every time. There are a couple of exceptions to that though. One is the sysmain.c file. So this is your entry point. This is where code starts running. So you can see here we've got user code begin and end comment sections here. So throughout the Halcogen code, if you put things in these sections, it will be protected and it will survive regeneration from Halcogen. It can get a little awkward sometimes where the way they've got these laid out, it's not practical for what you need to do. So you can see in some of our files, we'll end up hash defining out some stuff, inserting a chunk of code, some of which is ours and some of which is just a copy of what Halcogen makes, so that we get code where we need it. So it's a little awkward and tough to keep track of, so we have a page on the wiki where we try and keep track of every piece of Halcogen code that we've generated, other than like sysmain, which is an obvious one. So anyway, sysmain itself, not much happens here. We pretty much just start things up, enable interrupts, enable EUART for super low level debugging, and then we create our main task. And each build configuration has a different task main, as we call it. So this is the one for this particular launchpad. So we create it, and then we start the RTOS, and then we're good to go. So I'm just going to right click open declaration and go over to that one. So it's important to know that the task main for each build config is actually within the platform directory. This is a bit backwards and it goes against how we do everything else, where we strive to keep things out of the platform directory that we create. It's just easiest to put it here. If you don't, you can get reference errors and stuff like that. So we keep this here. So it's important to know that it's here and you're free to edit it, and you don't have to worry about Halcogen wiping it out. This is something that we create entirely. And so this, from your perspective, is essentially where things get going. So we've got several phases kind of defined out, and if you're adding code to this, put it in the phase where it kind of matches up with what's there already. So we do some hardware initialization, some internal initialization stuff. We say ORCASAT started, and then we bring up various tasks. So these are top level ones. So these are like pretty important core features that we're creating here. So the heartbeat blink and the serial printing interface. And then we start some telemetry stuff, and that's pretty much it. The launchpad config right now doesn't have too much in it. So now that we understand basically where things start running from, which is task main for most purposes, I'm just going to close out the platform directory. And I'll just mention that the build directory goes alongside the platform, And this is where everything that's compiled, so all your your .o files and stuff, object files, end up. So you don't ever need to go in here. It's unless you're a microcontroller, you're not able to understand any of it. The main folder that we are going to be concerned with is ORCASAT. So everything we write goes in here, with the exception of those couple ones that I talked about just earlier. So everything we write goes here, and then external libraries that we're bringing in are actually going outside of ORCASAT. So we got spiffs and a printf implementation. So these are things that we did not create. ORCASAT is all stuff that we made though. A couple of important ones. Notifications. So these, you can think of these as your interrupt service routines. There's a slight difference between this and a classic ISR, but basically these get called by the ISRs, and there's just a layer or two of abstraction. So it's important to know where these are because you may be adding interrupt features. And we do this in one file just to keep it clean and just so we know where all of our basically where all of our ISRs are. So you don't want to lose track of those. We have OBC task main, which is just a header that has the task mains for each build config defined in it, declared in it. Task priority, which has needs some formatting but has some default priorities of various tasks, and this is more applicable to the full OBC code and not the launchpad. But the real important parts are in these various directories here. So examples is pretty self-explanatory. File system, all of the glue logic and things like that we create to deal with the file system go inside here. So a lot of things like all this stuff is stuff that we wrote. We've got the hardware defs directory. The important thing here is only include obc hardware defs.h, and then based on the build configuration, it will pull in the correct actual hardware defs file where your hardware defs actually are. But it's important to know that when you're changing hardware defs or adding things to it, do it in the platform that you're working on, so Launchpad, for example. But then before you submit your merge request, you need to add those defines to all of the other hardware defs files as well, and make an effort to make it work. And then somebody with that hardware will actually try it and verify it. We have hardware drivers, which are drivers for specific chips. So we've got the STLM75, which is a temperature sensor. We got the RTC, things like that. We have interfaces, so these are things like I2C, low-level drivers, UART, ADC. We should have SPI's a little mixed up right now, but it will end up there in the future. Folder for radio. System has a lot of stuff in it. In the future, we'll probably break these out, make it a little more straightforward, but we've got state machine, telemetry stuff, dealing with the watchdog, command system, error logging. This is going to there are going to be a lot more things in here once we're actually, once development actually gets underway. We've got some unit tests. These guys are a little old. We're probably going to do this a little differently. And we got utilities. So it's good to know what's in utilities because you've got some useful defines and useful functions. So busy wait, which you probably shouldn't be using too much. Buffer clearing, things like that. Those are good to know. And yeah, that's basically it. So I mean, when you take a look at it, it's organized in a way that pretty much makes sense, and it should be pretty easy to find everything you need. And of course, as you guys are working on this, feel free to suggest any improvements or take a stab at organizing things in a way that may make more sense than the way it is now. Because it's always good to improve how we're doing these things. But yeah, that's really the main, those are the main points you need to know about hardware organization.